Okay, so then moving on to the next presentation, um, we have Oscar Zhang, who is the Deputy Manager of R&D at JinkoSolar. He is going to talk about reaching record cell efficiencies with TOPCon technology. Oscar?
Yes, I'm here. Yeah. Can
Great.
I share
So,
the screen?
yes, please.
Yeah. So, yeah, doing this. Can you see that?
Yeah, but please go in a presentation mode.
It is.
Yes. Yes, now you can see it.
Okay. All right. Thank you for inviting Jinko for this conference. It's good to have some technical discussions with a global expert. Today, I'm going to talk about some technology and also the roadmap for TOPCon. Okay, so firstly, I will start with some background. I won't talk about too much about the industry or whatever, because that's has been widely known. Just for the background, I want to share an interesting view for TopCon. Based on checking the previous report from like predictions, whatever, the like ITR PV and also the China PV industry development roadmap, we found an interesting phenomenon that last year, 2022, is an essential year for TOPCon technology. Before 2022, that although many people are familiar with TOPCon technology, but people still have, they have some high expectation, but the actual market share is still not much. But everything's changed from 2022. The actual market share matched the focus market share. So which means people have already finally seen the TOPCon technology in the product in the industry, and it's performing well. And also the prediction for the future of TOPCon become more and more optimistic. So the major changes are due to the product performance and competitive cost of TOPCon technology, which will bring us today. So for giving some highlights from Jinko, that for both last year and this year, we have very good performance in terms of the TOPCon product business, in terms of the shipment, and also in terms of the like also the profits, whatever. So particular for this year, which we show on the right side, we have already have close to 30 gig of N-type module and cell capacity, the shipment, and also the capacity has grown to close to more than 70 gigawatt by end of this year. So it's growing very fast, and we have very good like expectations for N-type. The reason for the growth of N-type is clearly it's a choice by the market, and it's a choice by the customers, because from the performance level, lower degradation, lower performance, a good performance, like lower temperature coefficient, and also high beneficiality, give very strong belief, and also the good reasons for customer to choose N-type technology by TOPCon. And also when we look at the future, the efficiency record has reached more than close to 27, which give very strong confidence for further growth of this technology. From our long-term global test project, we have seen actually compared to, I haven't? Okay, so we have actually we have seen the global performance of the in-field tests have shown that compared to PERC cell technology, N-type TOPCon technology has shown like a per watt electricity gain more than 3%, and some regions have shown close to 6% or even more than 6%, which give a lot of benefits for the customer. And that's why from a global view, people are now turning from a perk-based market into an N-type-based market. And from the reliability performance, we have seen it's also showing a better performance in terms of the degradation, reliability, and overall warranty guarantee. It is due to the technology growth, such as some material and also cell device structure development, all give us a better and better reliability performance. And also from a technology development point of view, the IP production for TOPCon has been readily mature in the industry, particularly for Jinko. We have like more than 200 patents for TOPCon, and also some basic structured patent has been well protected, which give a very good environment for further development. Now I goes to the second part of this is the roadmap for TOPCon technology. Recently, we have achieved again some new record for cell efficiency and module efficiency. Currently, with our TOPCon technology, cell efficiency can achieve 26.8, more than that, and also for module we can achieve more than 24.7. So which also give a good expectation for the future. It's all due to the development in the R&D stage and also technology innovation. But what's more important is how we can turn this technology into production. So when we look back what happened in the past few years, sorry, it's covered a little bit. For past 4 years, we have seen our record efficiency goes to the production gradually, and the gap year is roughly 1 to 2 years, which means if we can achieve certain technology in the laboratory with high efficiency, we are quite confident that it can be achieved in the production line in like 1 year or 2 years time. So we will expect something more than 27 very soon. Based on what we have analyzed from both experimental point of view and also the simulation point of view, we are using energy supply model. We see the energy loss distribution into each part of the cell structure and each part of the material performance. We see that at the beginning of this year, we started with something like 25, more than 25. And then we do very detailed loss analysis, and then we see that there's a very big room to improvement. And over the last year, this already December, so over the past year, we have actually achieved some improvement in several sections and several technology, which has been shown on the right side. And with all the development, we have achieved more than 26 average efficiency in the production line. And it is a very practical simulation. So we can see that in the coming future, it is well expected we can reach more than 27. And based on what we achieved this year, it's actually based on several major section improvements, such as the front side and back side passivation, particularly from P-type surface, and particular for the non-contact regions, the balance between passivation and conductivity has been well improved. And also the metal region recombination loss is another major contribution to the efficiency increase. Is due to the materials and also device design, which has been widely accepted and pursued by the whole industry. Based on the future simulation, we have seen clear roadmap towards 27%, and something more than 27 is well expected. Although as R&D people, we sometimes can become a little bit more conservative, but I still have confidence for further growth because of like the high potential innovations has been well developed, and the whole industry is working on these technologies, such as the P plus TOPCon and also new metallization technology and such, etc. And for the whole roadmap, we can see that we now this year, the average efficiency guaranteed to deliver to the market is average efficiency of 25.8. For next year, we will achieve 26.5 for average efficiency. And for the year following, we will see that when and how we can achieve more than 27. But in the future, we still look at some further development and long-term investigations, such as the tandem technology, which will expected to give us efficiency more than 30%, which will bring me to the third section, the potential of TOPCon tandem cells. So as everyone know that the theoretical limit of TOPCon is close to 29, so which practical simulation is 28.7. However, we are already sitting somewhere like close to 27, so that means we're not so far from the best value. So apart from going further, but we have to look at in the future what is giving us furthermore. So the tandem cell has been brought to cause some attention. So theoretical limit for tandem is more than 40%, so which gives a very good expectation for the future. And also, as you know, that further efficiency increase will create significant cost down for LCOE. So we definitely want to go that way. And the recent result we achieved with TOPCon combined with perovskite technology is a certified efficiency of 32.3. It's based on the structure of a standard TOPCon. I would say some optimization, but not big. So that means it can be well repeated, and this value can be further improved by improvement from both top cell and bottom cell. The major contribution to the achievement is based on surface passivation, bulk passivation, and also the recombination layer optimization. For the passivation part, we have been using the surface passivation technologies using different materials and additives, so that we can see for both the whole transportation layer and also the electron transportation layer, we have improved the performance by new technology and new material. For the bulk passivation, the perovskite part, we have seen very good additives developed by our team. So the hysteresis effect of the tandem cell has clearly shown the bulk quality has improved. And further, one good advantage of TOPCon plus perovskite is we can do a lot of optimization on the recombination layers, which we're using the ITO materials, because TOPCon is a high temperature process. So using the high temperature treatment can do some optimizations on the ITO layers compared to like HJT. You can only do low temperature process, so you lose a lot of opportunity. For this part, we have improved the technology, and the efficiency gain has largely contributed to this part of this development. In the future, there's definitely some more areas, optical wise, electrical wise, stability wise. There's definitely further room for improvement. Because the TOPCon can give very good modifications on the surface morphology and also the materials high temperature treatment. So we think that TOPCon may have an even better room for further improvement compared to other technologies. I mean, in the area of tandem solar cell. In the future, we still think for future development of all technology, we still have some requirement for fundamental research and understanding. We have done very detailed investigation and study for the reliability and also the quality control. So we have, even for solar cell, we have a whole complete process and laboratory for understanding where the degradation may happen and where the reliability issue can happen. But I still think it's not enough for further guarantee the customers are happy with the product. We still need more detailed investigation. And also I'm here call for collaborations from the global society. And for cell development, we have the material characterization, process control, and device analysis, all based on some fundamental study. We are using simulation and detailed characterization technology, but that's again, for going forward, still many challenges. So I still think we need more optimization and more work in these areas. For the future of products, we have seen we are doing like modules, BIPV, and also storage is like all relevant and combined business model. And now we are using like a smart fab to do all the production. So that give us room for further optimization and detailed control. Here by this, I want to summarize my work that we have good expectations for TOPCon technology, and we want to go further to prove to give a better and better product to the whole industry. Thank you.
Okay, thanks a lot, Oscar. This is a very great presentation, giving all the details of the difference between the research and the mainstream production. So I have several questions, but I think we will discuss in the fire chat today at the end of the towards the end of the conference. So to all attendees, please stay till the end. Me and Oscar, we are going to have a very quick fire chat. But Oscar, there is a question from one of our attendees. So can you comment on Jinko's tandem cells active area and stability results? Hello?
Hello, can you hear me?
Yeah, I can hear you. Have you heard my question?
Yeah, I think they're asking about the active area. Yeah. So for our tandem cell, we're still doing small area, so it's 1 centimeter square. And for stabilities, I would say we have passed, or normally we do that with like a more mini modules. So we have passed 1,000 hours of light and humidity test. However, that's not the best result for a stability study because that currently not the main focus. We are now still working on the efficiency gain improvement. But yeah, reliability study of tandem is definitely an interesting and hot topic. We will definitely work on that as well. Yeah, thanks for the question. Yeah.
Thanks. I think there might few other questions pop up already. I just see the chat, so there is already one more. So I would like to continue with the session. It would be great if you can stay back and answer these questions in the chat window.
Thank you.
So moving on to the next presentation. So this